Hello, students. We are meeting for our next lecture of second chapter of environmental chemistry, that is green chemistry and technology for sustainable development. Under that, in the last lecture, we have started the discussion of this chapter, and we have discussed one topic, that is green chemistry from theory to practice. Now, for today's lecture, we are going to cover very important, you can say, topic from this chapter. Not only from this chapter, from environmental point of view, all the syllabus. That is 12 principles of green chemistry. In the last lecture, briefly we have discussed the principles of green chemistry, but when you go for, as we discussed in last lecture, that when you go for green chemistry from theory to practice, which are the principles that has to be applied practically while thinking of developing the chemical industry or chemical technology, that is to be green chemistry and green technology. The first principle is minimize the waste formation. Now whenever you carry out any reaction, ideally it is expect that there should not be formation of any chemical other than the desired product. Okay, so this is not achieved practically, okay, in most of the reaction, but here you have to design the reaction or develop the technology in such a way that there should not be any formation of any other product other than the desired product. So whatever chemicals will be formed other than the desired product, they will be treated as waste product. So what are the possibilities? Either the reaction will not go 100%, so there may be the side reaction product. There may be the yeah, if at all reaction goes 100% as per your as per the person who is working, but there may be formation of byproducts also. So this formation of byproduct or waste product should be avoided. That is the aim of the this principle. So to make the to develop the technology in such a way that there will be zero waste formation. Or there is another feature of this principle is that if at all there is a formation of byproduct or waste product from a particular reaction, then it should be utilized as a raw material for another system. Okay, means for example, in sugar industry, while crystallizing out the sugar crystals from the cane sugar juice, there is a formation of molasses. Okay, so what to do with that molasses? But that molasses is the raw material for the alcohol industry. Means by fermentation of that molasses you can convert it to the alcohol. So in this way, if the chain goes to the end of the proper disposal of each and every chemical, then there won't be any harm to the environmental segments. So that is the purpose of this first principle, that is to minimize the waste product. There are other examples also. For example, if you take thermal power station, there is a formation of fly ash. But this fly ash, if you let it go in the atmosphere or landmass, that creates the threatening situation. But the same fly ash, if can be used as a starting material for cement or brick industry. So in this way, one has to think about, if at all there's first of all you have to think about zero waste formation. But if at all there is a formation of byproduct or waste product, that should be used somewhere else for its proper disposal. Okay, or one more example you can talk here, that is municipal or domestic waste, that is sanitary or sewage waste, which is formed, can be used for energy generation in biomethanation of solid, can generate methane gas. So that methane gas, as you know, can be used as a fuel. So that is the principle behind, that is the purpose behind this first principle, that is minimization of waste formation. Next point is atom economy. In the first chapter, in the introduction only, we have discussed what is atom economy. Actually, whatever number of atoms participating as a reactant, okay, in the form of molecules, if all of them are used to form the product, then the atom economy is 100%. So what is the formula for atom economy? The formula is mass of the mass of the atoms in the desired product divided by mass of the atoms in the reactants. Means here, remember, if all the reactant molecules or atoms they combine to form only the desired product, then obviously there is no formation of byproduct. Okay, but that is not going to happen in all the cases. Means, for example, if you are carrying out oxidation, okay, suppose oxidation of alcohol, our alcohol will be oxidized to ketone or acid further, okay, but for oxidation you need to use oxidizing agent, okay, and but after oxidation of alcohol to ketone or acid, what happens to the oxidizing agent? Okay, it loses its oxidizing power and forms some another compound which is not the desired product. So what to do with that that product which is not the desired product? So here that will not be counted, so that will be wastage, okay, as per the atom economy. So whenever you are you want to calculate the atom economy of this, suppose this oxidation reaction, then you have to take the molecular mass of the alcohol as well as that oxidizing agent, or if any acid is also used along with that. But in calculating the mass of the product, you have to take into account only the desired product, that is either ketone or acid. You cannot take into account what happens after oxidation with the oxidizing agent, that is forming the waste product, okay, that goes in the product side. So that affects the atom economy. Okay, so as per atom economy, there should not be formation of any other chemical other than the desired product. Means it goes with the first principle, there should not be formation of any waste product or byproduct, okay, but that is not going to happen all the time. So how this atom economy changes for different reaction, that we'll discuss here. Okay, this is the, you can say, inverted you can say cone. Okay, at the top if you see 100% economy, whereas at the bottom there is no 0% atom economy. So we'll start from 0. So if at all you are talking about any reaction, if that reaction doesn't proceed, there is no yield, zero yield, in that case the atom economy will be 0%. If you go still ahead for substitution reaction or elimination reaction, so what happens in substitution reaction? For example, SN1 SN2 reaction you have studied. So for example, tertiary butyl bromide treat with the KOH, bromide group will be replaced by OH group, but what happens with the K and that Br which is get replaced, that is leaving group, so that will form KBr, that is with along with the your alcohol, KBr will be formed. So that is the undesired product, but it is going to happen. You cannot have substitution reaction without formation of such product which is not desired. In that case the atom economy will not be 0, but it will be more than 0, but it will not be 100%. In same is the story for the elimination reaction is the breaking of sort of breaking of molecule. One molecule breaks down into two molecules, so obviously the other, out of these two, one molecule is the undesired product, so that will also reduce the atom economy. It will not be 100%, but it will be more than 0. If you go for higher reactions like chiral resolution or stoichiometric reagents or catalytic reaction, in all these reactions as shown in the diagram. Chronologically, the atom economy will go on increasing, and at the end, in which kind of reaction you will have 100% atom economy, that is addition reaction. It is exactly opposite the elimination reaction. In elimination reaction, one reactant molecule is break down into two product molecules, whereas in addition, two molecules come together to form the adduct, that is the desired product. So there is no question of formation of any waste product or byproduct. There is one more kind of reaction where most of the times there is no formation of byproduct, that is a rearrangement reaction. There is just a rearrangement of the groups or the atoms in the reactant. There is one more reaction, that is isomerization. For example, if you hit the cis isomer or Z isomer, it will convert to the trans or E isomer. Okay, so cis trans isomerization or RS isomerization. So such kind of isomerization will give you 100% economy. So under these headings you can have n number of examples, you can discuss it, you can find it, you can search it on net, and you can discuss with your friends also, so that you can have n number of examples here. Okay, one or two examples which are given in the book also. Okay, so here that is the purpose of atom economy. Atom economy take care of two things. One is, if atom economy is 100%, means there is no formation of byproduct. Okay, so there is no question of the disposal of the byproduct. At the same time, there is a you can say economic benefit also. Okay, there is no isolation, no separation, no purification, no disposal of waste material. So all these expenses are totally you can say reduced or removed. So that's why if atom economy is achieved, you can achieve the real monetary economy also. Now we'll go ahead for the next principle, that is avoid the use and formation of toxic materials. Means if you are using toxic material, no doubt at the beginning or at the first stage it is going to harm the workers. And same chemical, if it goes in the market, while transportation, while handling, while when it reaches to the consumer, when consumer starts using it, in all these steps there are chances that there may be hazardous effect on the consumer also. So if possible, both technically or you can say economically, the synthetic methods should be such that the use and generation of toxic and environmentally hazardous substance is avoided. So as far as possible, one should avoid the use and formation of toxic material. So this principle aims to develop the new technologies which will make use of environment friendly starting material, correct, and also avoid the formation of hazardous or toxic byproducts. The byproducts formed using such methods will be non-hazardous, okay, and also readily biodegradable. Sometimes only the desired product will be obtained with no byproduct. Means if you are using non-toxic material, they will avoid the you can say formation of byproduct. Okay, so if you think before going for actual industrial operation, if you think about it, if you avoid the formation of toxic material, there are less chances of formation of byproducts. And the byproduct, if at all they are formed, when you avoid the formation of toxic material, if the byproducts are formed, they are readily biodegradable. Mostly toxic materials are not biodegradable, that is the problem. So here like a plastic, so here one can think about it, as far as possible avoid the use and formation of toxic materials. Then next is design and use of non-toxic material or the material with minimum toxicity. Means consider the third principle. Here we are talking about the zero use or zero formation of toxic materials, but that is not going to happen all the time. Okay, in all the chemical reactions, it is not possible that all the reactions which will be developed, there will not be any use of toxic material, or there will not be any use of toxic material, or there will not be any formation or generation of toxic material. So if that is not possible, then you can think about the chemicals used for various activities should be non-toxic. Okay, but should have the efficacy to function. Okay, many chemical industries use toxic substances, such as substances as starting material, or sometimes the starting materials are derived from toxic substances. For example, I can give you one of the substance that is used in polymer industries, adipic acid, which is used in manufacture of nylon, polyurethane, or lubricant. Benzene is starting material for adipic acid. Benzene is highly carcinogenic. Okay, so it not only carcinogenic, prolonged exposure to the benzene will cause the cancer to the worker as well as consumer, as well as it pollute the air. But in that case, in order to avoid hazards due to benzene, green technology has been developed. Okay, where adipic acid is synthesized enzymatically from glucose. Means you can achieve this. Okay, that if you start using the starting material which is available in the nature, then there is no question of using the toxic material. Most of the natural substances, they are non-toxic. So here, in a way you can avoid, but you have to go for rigorous and serious thinking, or designing, or developing the technology where these non-toxic materials will be used, or substances with the minimum toxicity. Then you can go for next principle, that is minimum use of auxiliary substances. So first of all, what is auxiliary substances? So in a chemical reaction, there is a reactant. After reaction, there will be formation of product. But to carry out the reaction, you have to use these auxiliary substances. So what are those auxiliary substances? First is solvent. In most many reaction, you have to use the solvent. So you have to go for, because after the reaction, what happens with the solvent? Okay, first of all, you have to purify your product. Means that is economic loss, monetary loss. But at the same time, if the solvent recovery is not possible, then this there is no alternative other than to let it go in the water bodies. Okay, as a effluent, but that is going to create the threat to the environment, that already everyone knows. So here, as far as possible, you have to think, you have to design, you have to innovate, you have to develop the technology or chemical reaction in such a way that you will go for uh, development of the such reaction which will be totally solvent free. Okay, should not be use of any separating agents. Okay, if you have to use the separating agent, again there is question of purification, or after the use, if that chemical loses its chemical power, then what to do with that? Can it be recycled? So these question comes in mind, and that one has to take care, that how one can avoid the use of such auxiliary substances. If you avoid it, then there is no question of the monetary as well as environmental loss for maintenance or disposal of the auxiliary substances, such as solvents or separating agent. So use of such substances should be avoided. So this principle of minimum use of auxiliary substances aims to use green solvents. Okay, means if you are using just now in the fourth principle, we have discussed the example of benzene. Benzene can be used as a solvent. It is a good organic solvent which can dissolve most of the non-polar substances, but that is at the same time very carcinogenic. So instead of that, can you use green solvents, for example, water or supercritical carbon dioxide in place of volatile halogenated organic solvents like DCM, dichloromethane, or chloroform, or perchloroethylene, or carbon tetrachloride? So these are chlorofluoro carbon solvents are very, you can say, problematic for environmental view. So, can you use any other solvent which is not so toxic? So that will be auxiliary. And if at all possible, you avoid the you develop the reaction which will be solvent-free reaction. For example, here I will give you one example, that is Claisen rearrangement. In this Claisen rearrangement, unsaturated ether, that is allyl ether, is converted to gamma delta unsaturated carbonyl compound. So this is a rearrangement reaction, so there is no byproduct, so the atom economy is maintained, as well as there is no need of use of any solvent. So that is that avoid the use of auxiliary substances. So this is a very important principle that has to be followed while developing the new technology or new chemistry. Okay, the next principle is minimum use of energy, or you can say minimum energy consumption. The synthesis of any chemical compound requires energy in the form of heat. Okay, without supplying heat, most of the reaction will not take place. Mostly the endothermic reactions. Okay, where you need to supply the energy. Energy can be supplied in the form of heat or pressure or the chemical concentration. There are n number of ways of supplying the energy. You can supply in the form of electrical energy. So according to this principle, in order to make the process more economic, it is necessary to reduce the energy consumption. That is a very important aspect, because while creating the energy, what are the various you can say non-polluting energy sources? For example, hydro electric power, that is you can say non-polluting. Okay, but if you are using thermal power, if you are using nuclear power station, then uh, it is going to create the pollution. Okay, so at the cost of pollution, the energy which is produced should be used economically. So there should be minimum energy consumption. So to save that energy, synthetic process need to be modified. Means whatever chemical reactions which are developed, or you can say innovated, that should be modified in such a way that by reducing the temperature or by reducing the pressure to ambient condition, a large amount of energy can be saved. So either you can go for use of catalyst. Energy of activation is reduced by use of catalyst. But that again, you have to think about the catalyst. What will happen with the catalyst? Can it be recycled? Can you bring about the reaction using biochemical process? Can you use biocatalyst? Or another way is saving energy is to go for refluxing or use of microwave radiations. Can you use it? Can you use photochemical reactions? Is it possible to use solar radiations or extracting energy from waste product? Okay, so there are n number of various ways by which you can produce the green energy. The green energy, here again the concept is at the cost of production of no pollution, that is a green energy. For example, hydroelectric power. But thermal and nuclear are, though they are good source, non, or you can say renewable or non, you can say there are new methods or new methods of producing energy, but there are some problems of pollutions with these methods. So can you use catalyst, biocatalyst, refluxing, modify the reaction, use of various radiations, photochemical reaction? So these are the ways by which you can avoid reduce the energy of activation, thus by minimize the energy consumption. So in these various ways you can control the energy consumption. So for this today's lecture we have discussed the six principles. Then in next lecture we'll discuss the rest of the six principles. Right now I will advise you go through the book or reading material which I given. You can next time I will provide with you the some good kind of videos where you will understand these principles with few more or new examples that will be very useful for you. Or you can also search, but next time I'm going to provide you those links so you can watch those videos also. That will be very useful. So for today's lecture we'll stop here. We'll meet next week, next Wednesday, for our next lecture. Thank you.